Here. Hey, some gum. Put some seeds on you. Good. Hey, good. You're not eating acorns, are you? They're poisonous for you. Everything's out the car now and into the workshop, and I've been able to go over all the pieces and sort of see what they look like after the powder coating. It's gone a bit military inadvertently. Anyone that knows me knows that I do like military stuff and sort of military greens and stuff. Because I've got them to paint the inside white, it now looks like a British World War II tank, which is fine, and I like it, but it wasn't really my intention, and I think the green could have had a little bit more yellow in it. It doesn't matter. I like it. I think I'm actually really happy with the colour. I would change it given the choice again, but it's good. It's cool. There's things that are not so good about it. The work that they did isn't too bad. The masking could have been better. There's on the spear especially, which is here. There's a lot of overspray on bits that I wanted protecting, and weirdly, I don't quite know what happened with the tip of the spear valve, but it's got some melted plastic on it. They blasted away a lot of what would have been old filler on imperfections in the casting, and what I wish had happened is they'd given me a ring and said, look, this surface isn't really good enough for us to paint over the top of. Do you want us to fill it, or do you want to come over and fill it before we do the powder coating on it? And that would have been great, because what I'm going to have to do now is go over some of this. I'm getting some primer, and I'm going to need to prime over the pits that are in this thing, because what's going to happen is water's going to collect in some of these cavities. There's powder coat in the cavities, but water's going to collect in them, and inside the turbine it'll cavitate and just damage the paint will come off quite quick. But outside I don't think it's ideal. If the powder coat doesn't look like it's going to last after a few years, and it's sort of bubbling off and there's rust forming underneath it, I'll get it stripped off again, maybe with a sort of chemical solution, and then repainted with another type of paint. I don't know what that would be at this point. If anyone has experience with that sort of thing, let me know what you would paint it with. There's sort of ceramic epoxy coatings. There's a company called Belzona that look like they do a specialist epoxy for water turbines. That looks dear though. It doesn't look dear, it is dear. One thing they did do, which I'm rather happy with, is that they fixed the lock nut for the governor. What's good? There was also some miscommunication. Get on there. There was some miscommunication and some of the machined faces got painted. Luckily, after going through it, everything that got painted that I didn't want painted is not too bad as far as taking the paint off it again. It's the side that this goes on. They haven't done the inside of this, which is the cap that sort of goes over the bearing. And I think this is a tolerance fit. I think this goes against the bearing, keeps it flat. And what they've done is painted the face that meets up to this. I'll film it. So I need to scrape that off. I think that's enough talking, and it's time to do some doing. I'm going to start off with having a look at the bearings on the rudder and hopefully cleaning them up and getting rid of all the overspray and dust that's collected on them. There's nothing that has happened with the powder coating that is a complete disaster. It's just maybe not quite as good as I was hoping it was going to be, and powder coating might have been the wrong choice, but you can follow along and watch me strip it all off and repaint it at some point. If that's the case, it's not. Nothing is irreparable or irreversible for this. Yeah. So let's do some work. For reference, this bearing says RL18K on it, and there's also another thing that says BH3. They primed it with a galvanic, like a zinc primer, and so there's a layer of that and then the steel underneath. So if I just go through basically till I start scraping through the primer into the steel, we can basically call it done. I don't need to get it completely clean, I just need to get it flat. It's raining, it's dark, and the generator's running, so you're going to have to excuse the sound quality, but I was going to leave the inside of the housing alone, but on closer inspection there's so much porosity in the powder coat that I'm going to go around and fill it all. What I should have done is not get the company that blasted it to powder coat it at all. and I should have just got them to give it to me in the raw metal and then just go around myself and brush paint it, because essentially that's what I'm doing now anyway. What's going to happen is that water's going to collect in those divots and cavitate, because this whole thing's going to have water flying around inside it, and it's just going to pop the paint off quite quickly. It might even be worse to have this in this condition than to just have the raw metal, because it's going to trap the water underneath it. So I'm going to fill all these holes and paint over the top of them with a primer and a paint. Let's see. I haven't really thought this through. Use it there. Use it there. Yeah, that's pretty good. I haven't described the sort of series of galleries and stuff in this, which are rather clever, I think. Obviously there's water coming in at the bottom, hitting the spoons, and this is spinning. Water's going everywhere, and then it's got this rim on it here, and so this rim would fling water out and essentially would be the first line of defence from water coming this way towards the bearing. The next line of defence is this thing here, which I don't know its proper name, I'm going to call it a flinger. And so this is sort of designed for if any water makes it past this point, it'll, as this is spinning, water will work its way down this edge and then be flung off the tip, and that is sort of the next line of defence. And then in this sort of gallery area here, there's a hole in the bottom, so any water that's flung off this makes its way down there. The final line of defence is this is just full of a waterproof grease, which sort of, I guess you can see when I originally took this apart, it was all brown and horrible. It looked like curry sauce. So water does make its way in here, but there's not really a lot to be done about that. And it's, you know, it's lasted quite well. This bearing face here is one of the cleanest things of the whole operation. There's a load of overspray on this one from the powder coater. I think I'm just going to leave it. But you can see the bearing's working pretty well. Okay, first off, it's good. None of the paint or anything that's gone on has affected the rotation. There is a bit of vertical movement. There isn't any horizontal movement, and there's probably a little bit of lateral movement. Yeah, moves ever so slightly that way. That means shimming this is definitely necessary. Oh, generator's run out of petrol. So that's 0.3 of a millimetre. Let's just see if I can get the thinnest one, which is 0.05 into the side. No. Ow! So I think I'm happy with those shims. They're pretty faint, but these are sided, and there's a 0 on each one. And there's a 0 and a 1 on each one, and this side is 0. Okay. So it does feel like a tiny bit more movement than before. I think I need slightly thicker shims. I've test fit these side covers and they have slightly pushed the castings apart. I'm a little worried that because these side collars, whatever they are spacing the top and the bottom off each other. I think if I get some silicon gasket 0.1 millimeter thicker than this paper gasket, I think that'll form a nice seal and it'll squidge ever so slightly shut and just stop any moisture wicking into this gasket. I could still use squeezy RTV, but I don't really want to. So I'm going to get some of that, I think, and in the meantime I've got a few little tasks like putting threaded bar into here. I'm not going to put... I've cut some new gaskets in silicon, which is ever so slightly thicker than the paper gaskets. I think it's a much better material to use anyway, because the paper one had already torn with me just fussing about with it, so hopefully the silicon will be a bit more durable. I've done a lot of fussing about with this and I'm happy with it. There's no play in it whatsoever now. This thing is nice and snug. The gasket is nice and compressed, so I think that should form a nice seal. Hopefully tomorrow I can think about, weather permitting, putting it back in place. I would say this is contender for one of the worst things I've ever made. Next, I'm going to partially rebuild the governor on this side of the turbine. I haven't completely written off the idea of using the bearing mechanism and the weights in the governor. The trouble is the weights are weighted for this running at a different RPM, so using it in its current configuration, it won't work. I could look at changing the springs, or if I cut the springs down, there'll be less tension in them, which would mean that they would expand at a lower RPM. But I don't know how to calculate that other than trial and error. And I think I'm probably, my plan is to do this electromechanically anyway. So I'm just not going to rebuild any of that. But I do want to put the governor, I do want to at least put the governor housing on here, just as a counterweight for the weight of the pulley. So I'll do that. So let's do that. Some of the bolts were missing from this, and so I bought some new ones. And just look at the quality of the old bolts, and then this is the same bolt that I bought, but it's a modern one. There's just no comparison. I've learned from a couple of comments on the spear valve video that this bushing here shouldn't be attached to this shaft. The shaft should run freely in this bushing, and this should actually be mounted in this hole, and the sandblasters has shown up there's a remnants of a flat-headed grub screw in there. I could try and get this off the shaft, remount it in there, and either drill a new hole and secure it with a new hole, or drill this out and retap it. Doing that might fix the concentric movement of it within the valve housing. My worry is that I don't know the condition of the shaft inside this bushing. If I get this off and it's all corroded in there and damaged, and this doesn't run freely inside it and it galls up and stuff, then I've sort of made it irreparable without remaking the shaft or you know, retooling it and all the rest of it. So it's an option. It's not an option I'm going to take now, but it is an option that I could possibly explore later down the line. I've also had a bit of an idea of automating the spear valve with a servo. I'm definitely not going to do that now, but that could be a sort of project that I do later down the line. For now, I'm just going to put it back together as it was before, because I know it does work like that, and I can revisit this later. But yeah, for reference, this should be mounted in here. Hopefully it'll go back together. Oh yeah, this was the other thing. There's a packing seal here that goes in the back and is mounted against this. I better put that in. Something I should maybe have thought about doing is pigging the penstock, which is running a sponge down it to clean any detritus off the inside. I don't think that this has been used very much, and so I don't think there's actually going to be very much build-up of anything in there. I'm going to clean the pipe just by running water down it, because it's been disconnected for a few months. It will have collected some debris in it, because the top end is open. I'm pretty sure I'm ready to do a test run. These might need doing up a little bit. When I bought this valve, I didn't realise there were different types of flange face, and I got one that has like a little raised bit on it, which means although it looks like there's a gap here, the interface is squeezed quite shut. If I were to tighten this up until this gap was shut, it might crack either the valve or even worse, the turbine valve. Water might come out of these or this. We'll obviously see what leaks arise. I'll go turn the intake on. This is shut, so I'll pressurise the pipe. Got a tachometer. I need to find a battery for it, and we can test how fast it's running. I don't want to really spin it up too fast to start off with. I'm know, a bit apprehensive about what's going to happen. The tachometer I bought is DOA, it doesn't seem to be working, so we just won't bother with that. I'm just going to open it slowly and basically see what happens. We've fully pressurized now. I'm just going to take it easy. This isn't just drama, this is the first time I will have tried this, so wish me luck. This is shut. Okay, we've got a couple of leaks from this. Freewheeling now. Okay, we can call that a success. It's quite scary. I don't know how fast that was. Quite a lot of water comes out of it. I think I'm going to run around with some silicone and silicone in the base. I'm going to get another tachometer. It's quite loud. Yeah. If I expect it to be that loud. Right, have another go. A couple of weeks have passed since the last bit of footage I did in here. I've hammered some tin onto the sides of the little shack here just to give us a bit more weather protection. I might put some polycarbonate on that window. This is the little tachometer. This one works. I thought I'd do an overview of what kind of power I expect to get out of this and how I can use this little pressure gauge to indicate flow. So in the introductory video, I sort of said the system parameters for what we have, which is it's a 90mm. Well, actually, it's. Do I have this written down here? No, but it's the nominal bore of this pipe is not 90mm. That's the outer diameter. The inside, I think, is 79mm. So it's a 79mm pipe that runs about 200 meters. To 34.5, 35 meters high, and then the flow that we could get from that is maybe up to about 20 litres in the winter. As water runs down the penstock, friction increases through the walls of the pipe, and what that means is that effectively you lose pressure to friction. It's a little bit like an electrical cable. The fatter the cable, the less resistance you have from the cable. The same applies to water. I can read roughly what the flow is based on how much the pressure drops on the pressure gauge. I've done a little. I've used ChatGPT for this, so comments in the description for how wrong this is. So when my pressure gauge is reading 50 psi, which is what it's reading at the moment, it should be. Yeah. When it's reading 50 psi, there's no loss to friction. That is the static head. Once we start increasing flow, then we increase the friction, and that is basically translated into what's known as head loss. Through reading what that loss of pressure is, I can roughly work out what the flow of water is coming down the pipe. If I open up the valves and watch the pressure reading, and it reads, let's say it goes down to 49 psi, that translates to losing about 0.8 meters of head, and that can be translated into 2.5 litres a second worth of flow. The more you open up the valves, the more you increase flow, and the more you increase head loss, which is a translated reading on this gauge, and that tells me what the flow is. So basically, if I open this up and the pressure gauge reads 40 psi, then I know I've got a flow of about 8.5 litres a second, which is cool. I've also calculated on my little table here what the estimated power output of the turbine is going to be. I've been quite, I don't know if this is generous or not. A modern turbine is maybe up to about 70-80% efficient. Our Gilts turbine here might not be that high. I've got it to calculate this out at a 60% efficiency. The proof will be in the pudding once I'm generating electricity out of it. The maximum turbine power I think I can expect is at 12 litres a second, and that's about 1.56 kilowatts. We'll see if that's true. You get to a point where you increase flow so much that you actually start losing power, and for me, with this size pipe, that is at 30 litres a second, we've got a head loss of 14 metres. We actually start losing energy as we increase flow. So if you increase flow up to 50 litres a second, the power output from the turbine goes down to 1.4. The losses are so high that it doesn't become worth it. In fact, it becomes detrimental. Obviously with a bigger pipe, which I've talked about over and over again, but with a bigger pipe, we don't get as much head loss, so we could run it at much higher flow, and there is available flow in the river to do that. That's an upgrade that could happen much later on, or I could put another pipe in and have a manifold. I could put another pipe in and actually have another turbine. There's loads of options to do because we have a lot of flow available to us with this river in winter. I could do lots of things with it. We'll see. When I first ran this up, the speed that it was spinning was, I think, the maximum I've measured it running is 920 RPM. In order to extract energy from that rotational movement, what you want to do is get the generator to basically resist the spinning of the turbine by about half. It's a little bit more complicated than that in real terms, but in simplistic terms, and if you imagine a kid's roundabout spinning, it's like, to start off with, you're spinning that roundabout and you're putting a lot of energy into it to get it up to its speed. What eventually happens is that you end up just being unable to put any more energy into it because it's going so fast. That's what's happening when this is at its no load speed, which is the highest I've measured is about 920 RPM. So what you want to do is you want to have a constant, you want to limit the speed of that roundabout so that the energy that you're putting into it is absorbed by the roundabout. So essentially this wants to be running at roughly 400 to 500 RPM. I'm quite bad at explaining things. What I'll do, I'll film it spinning up. I've got the little tachometer, so I'll film it at its runaway speed, and then I'll film it at the speed that it's actually going to be running at once the generator's on it, and it's running at a nice efficiency, and it's quite sedate actually. It's quite it looks it looks slow. Enough talking. More spinning. speed it's actually going to be running at when it's under load is really civilised. It's quite slow. This is going to act, I think, as a conclusion to hopefully the next video that you see. Well, it'll go one of two ways. Either this will be producing power and I'll have a smile on my face, or it'll be a video explaining what's gone wrong. I think it'll be alright. Thanks for following along. There's more people interested in this than I thought would be, which is quite nice. I'll do the final outro, a film of the spear valve hitting the runner.